Hi YouTube, continuing question 5 for the Pure 3 matrix algebra, a transformation T represented by the matrix A. To find the value of K for which the line y equals 2x is mapped onto itself under T in A. To show that A is non-singular for all values of K and B. To find the inverse of A and C, and a point P is mapped onto Q under T, given that K equals 3, to find the position vector of P and D. So for part A, T maps y equals 2x. So applying A, T to T gives tk minus 4t, t plus kt. And considering the line is mapped onto itself, then t1 plus k will be equal to 2t k minus 4. And solving this expression gives k equals 9. So for non-singular in B, the determinant will be 0, and applying shows A is non-singular for all values of k. For the inverse in C, using the determinant from B, we can write down the inverse. For the position vector of P and D, T maps P to Q, multiplying both sides by the inverse of A. Then P is the inverse of AQ. And given K equals 3, substituting in the inverse obtained in C, and given the position vector of Q, applying gives 1/5 6 minus 1, and we can write down the position vector of P. Question 6, De Moivre's theorem, induction in A, proving cos 5 theta is the expression in B, and to show 2 cos pi over 10 is a root of the equation in C. So for part A, substituting n equals 1 is true. Considering n equals k plus 1, then by De Moivre's theorem, cos k theta plus I sin k theta times cos theta plus I sin theta for n equals k plus 1, and expanding these brackets and simplifying, considering the addition identities for cos and sin, then it is true for n equals k plus 1, and by induction true for all n from the positive integers. For part B, proving cos 5 theta for the expression given, by De Moivre's theorem, cos 5 theta plus I sin 5 theta is cos theta plus I sin theta to the power 5. So applying the binomial expansion and simplifying and equating the real parts for cos 5 theta and substituting some identities simplifies to the proof required. So for part C, showing that 2 cos pi over 10 is a root of the equation given, if we substitute x equals 2 cos theta into the expression given, it gives the starred expression. And considering the proof from B, dividing both sides of the proof from B by cos theta gives the starred expression. Then cos 5 theta will be 0 to satisfy the expression, and solving cos 5 theta equals 0 gives theta equals pi over 10. So considering we substituted x equals 2 cos theta in the expression, then 2 cos pi over 10 is a root. Final question in this paper, Geometry 3D, a pyramid PQRST. To find the vector product of PQ and PR in A, an equation of the plane for the face PQRS in B, and then given the plane of the face PST, to find Cartesian equations of the line through P and S. And given that PQRS is a parallelogram and the coordinates of T, to find the volume of the pyramid. So for part A, given PQ and R, we can write down the direction vectors. And applying the vector product gives 3i plus j minus k. So for an equation of the plane, we can use the vector product of the direction vectors for the normal, and using point P, the dot product is 4, so we can write down the equation of the plane in the form required. So for part C, Cartesian equations of the line through P and S. Given the equation of the plane through PST, the vector product of their normals will give us a direction vector for the line through P and S. So applying for the vector product gives minus 7i plus 14j minus 7k. And adjusting this direction vector for I minus 2j plus k, using the point P, we can write down Cartesian equations. So for the volume in D, using the standard result for the volume of 1/3 times the vector product of PQ and PR and the dot product of PT, using the result from A for the vector product, and given the coordinates of T, the direction vector PT will be 420, and applying for the volume formula gives 14/3. So the vector product in A, the equation of the plane, and the equation of the line, and Maple's using a different coordinate rather than P. And the sketch here shows the pyramid. Thank you for watching. I'll start another series in another video.